Hey everyone, Katrina here, and today we're going to learn integration by parts. Be sure to subscribe for more videos like this and watch to the end to see all the examples. Okay, so integration by parts is an amazing integration technique that allows us to take complicating looking integrals and solve them easily in just a couple steps. So for integration by parts, we're going to want to find a function that looks something like this, meaning that we have two functions and they're separated by a multiplication. That is the key. We need to have this multiplication that separates our two functions in order for us to go ahead and use integration by parts. So oftentimes you'll see this terminology of this integral of function u of x multiplied by v of x dx, meaning that x is the variable that we're integrating with respect to. So we're going to start off with a little bit of terminology and just labeling the parts of our integral here so that we can move into a really easy framework that I'm going to show you today. So this function u of x here, we're just going to call this u, so not too hard. And then we're going to take the rest of our function, so the v of x dx, and we're going to label this dv. Okay, so we have u and we have dv. So in order to solve something using integration by parts, we're going to remember this easy to follow equation. So the integral of u times v is going to equal to uv minus the integral of v du. So in this case, we have to be aware that this v over here is going to be the integral of our dv. And then our du over here, this is going to be the derivative of our u. Okay, so this might sound a little bit confusing, but I'm going to go through an example, and I promise you this is going to be something that's very easy to memorize going forward. You see an integral, it has a multiplication. Just know that the answer will be uv minus integral of v du. Okay, so let's put this down in our notes and let's dive into our first example where this will all become very clear, very fast. Okay, so let's have our first example be we have the integral here of x multiplied by cosx dx. So let's take a moment to see what's happening here. So we can see right away that we've got two functions here and they're separated by a multiplication. Whenever we see this, we can think right away, okay, I can use integration by parts. You'll often see it use this acronym IBP, which stands for integration by parts. So let's go ahead now and then label this similarly to how we did at the beginning. So this x over here is going to be our u, and then the cosx dx, that whole piece is our dv. So we've got u and dv. So what I recommend when solving this is actually just write out a chart or notes of what is your u, what is your du, what is your v, and what is your dv. So we're going to start with that. So u in this case equals to x. And remember I said our du is simply the derivative of u. So what is the derivative of x? Well, it's just 1. If you need some refreshers on derivatives, be sure to check out all my derivatives videos. Okay, so then we need to look for our v and our dv. So we already have our dv, which is simply our cosx dx. And then in order to find our v, we have to take the integral of cosx dx, and the integral of cosx is simply just going to be sine x. Okay, so now we have all our parts. We have our u, our v, our du, and our dv. So let's go ahead now and put it into our handy little equation that we learned previously. So we know that we have to take uv minus the integral of v du, and just remember that we're still integrating this with respect to dx, okay? So now let's go ahead, and all we have to do is pretty much just fill in all the blanks that we've got here. So what is our u? So our u equals to x. What is our v? We have our v over here is sine x. And then now we take minus the integral of v, which is sine x, and then multiplied by du, which is simply 1. And then remember that we're still integrating this function with respect to dx. Okay, so now we've taken an integral that had a multiplication, right? So we had this multiplication over here, which made it challenging. And by using integration by parts, we were able to now simplify our integral. And now we only have one integral left, and there's no more multiplication because this sine x multiplied by 1 is just itself. So now this is a much easier problem to solve. So if we continue along, we will end up here with x sine x minus, what is the integral of sine? Well, that is simply negative cos x. And then since this was an indefinite integral, we did not have definite bounds. We have to make sure that we always add the plus c, our constant of integration. So make sure you don't forget that. Over here, we see we have two negatives. So the enemy of my enemy is my friend. This becomes positive. So now all I have is x sine x plus cos x plus c. There we go. We solved our first integral using integration by parts. Let's do another example, just so we can add another one to our notebook and so that we understand this really well. Okay, so for our next example, we're going to use an exponential function. So we now have the integral of 2x times e to the x dx. So again, the first thing we have to notice is that we have two functions that are multiplied with each other, meaning that we can use integration by parts. Before we even get into that, let's use one of our rules of integration, and let's take our constant 2 and let's put it to the outside so that it is not in our way. So that means we have 2 multiplied by the integral of x times e to the x dx. We're still integrating with respect to x. Now let's go ahead and label this. So we have that our x is our u, and then we also have here our dv. So this whole rest of it is our dv. So now let's write out our list like we did before. So we have that u equals to x, and then du is just the derivative of that. So we have 1 again. And then we're looking for v, and we already have dv. So dv is e to the x dx, and then v is simply going to be the integral of our e to the x dx. And this is a lovely case because the integral of e to the power of x is simply e to the power of x. So we're good to go. Now we have to go ahead and use our formula for integration by parts, meaning that it's uv minus the integral of v du. And remember, this is still integrating with respect to x. Okay, let's go ahead and put this all together. So remember, we have our 2 on the outside. Let's not forget that. That's easy to forget sometimes, so we'll stick it there at the beginning. Our u is x, v is e to the x, minus now the integral of v, which is e to the x, and du is 1, and we're still integrating this with respect to x. So now we just have to solve this integral. So it's simply 2 times x e to the x minus, and like I said, the integral of e to the x is e to the x, and we have to do our plus c. So if we expand this out, we get 2x e to the x minus 2 e to the x plus 2c. And then since c is not defined, it's our integration constant, we can just say let c bar equal to 2c. Therefore, our final answer is 2x e to the x minus 2 e to the x plus c bar. Okay, and that is our final answer. So I hope this video helped you understand what integration by parts is and how to recognize when to use it. And I hope that this is helpful for your next exam. Be sure to like this video if you enjoyed it, comment any questions that you have, and definitely subscribe for more videos. I look forward to seeing you next time.